Okay, fine. Just the mistake in this address from the unexpected this one and this one semicolon. That issue got resolved. Okay. So undefined variable address with depth and everything is there. Okay. Interface.sv face. Okay, address width and all. So copy. So that means all the people from Bhubaneswar is facing the issue still.
Yes, sir.
So right now I am in the EDA site. Like which screen you are seeing right now?
Sir, memory sequence.
Memory sequence. Okay. So is the thing getting scrolled?
No, sir.
Right. Okay.
Sir,
Your it was look.
Yes. Now
This conference will
I
now
got
be
it, sir.
recorded.
Yeah. So any other doubts apart from this?
No, sir.
Yeah. Oh, closing this one. Okay. Fine. So these are the field registrations, like field int real enum, okay, object array enum kind of things. You can go in the UVM object defense that was there in the macros. Okay, in your macro folder, you have this object defense. Inside that, you can able to see all different kinds of field registration. So you can uh, go through this, and if you got any doubt in the syntax kind of things, you can go and you can use this one. Okay, yeah.
I'm not working on a command, no, sir. Like it is already the UVM component is already present in the Questa sim. So we need to call.
Yes, we need to include
So
that. You
yeah.
are
So
asking about the package, right?
yes, sir.
Huh.
For the include part,
Hmm.
include directory, you have given us one code, the path of the Questa sim. You
Slash home slash.
yes, sir.
Ha ha ha.
So while giving that path to undo file, it is showing like error. Like it is showing error, sir.
Okay, it was in 80, right? 1 minute. So somehow it was remotely closed. New session 80. It's 20. No, I want 80. New session, and it is 80. So, okay, fine. Did you logged into 80 or no? 6.
Logging in, sir.
Yeah. Oh, no, no, no. Yeah. Okay. If you logged in, please share the ID with me. I'll open that ID. Okay.
Yes, sir.
It was remotely getting pushed.
So it was showing the error. Could not find include file UVM package.sv.
Okay, okay. Tell me the ID, the server ID that you logged in after 80. you'll give some number, right? Colon some number. Tell me that
Seven,
number.
sir.
7. Okay.
Password is different, sir. I have changed that password.
Okay.
It's a Nitin 458.
ENI.
NITIN
Hmm.
at 458.
4558. Hmm. Okay. What you can do is like you can share your screen. I'll make you presenter. Okay.
Yes, sir.
It's better. Yeah. Now you are the presenter.
Yes, sir.
Hmm.
Is it visible, sir?
Yeah, it's visible.
Yeah. This one, sir.
No, in that area you didn't have the package, right?
Okay, so we need to remove that package, sir.
Yeah, just go to the run.do.
Run dot two. Okay, sir.
Just run desktop UVM 1.2 RC8, UVM 1.2 SRC. This is Windows path, right? This is not UVM. I mean, this is not the Linux path where your SRC is source code, right?
Like include directory, home tools, mentor install.
Yes, we need to write that one.
Yeah. So that one I have written, it was not happening, so I have written like another one. Okay, sir, I will write now.
Yeah, write it.
And home
Tools.
tools.
Just open your. Okay, fine. I'll tell you one thing. Just open your command. I mean tool. I mean this terminal.
Terminal. Yes, sir.
Yeah, ls. Just type hit enter.
LS.
Yeah,
Yes, sir.
enter. Hit enter. Okay. Close your request as well. Just whenever you are trying to give vsim ampersand. Okay.
Oh, okay, sir. Okay. Okay. So, what is the use of this ampersand, sir?
So it will allow. The thing is like now, if you see, you can't able to observe this ls. Whenever you are giving the things, it is asking. It is not getting close. Like previously, your question is running until the, so if you use vsim ampersand, then that ampersand will gives you like okay, you can use the terminal kind of thing. It's a kind of extension, okay.
Okay, sir.
ls ls
LS.
something kind of not Verilog SRC. Uh, you can go with 1 minute. Linux. Mhm. Mhm. Enlarge it. Ah, it's like go with UVM 1.2, UVM hyphen 1. Yeah, press tab with what is this? Linux, Linux tab, Linux underscore x86 tab underscore again tab. So yeah, you need to copy this one slash home to 64 slash. There you can see UVM underscore dpi.so. You need to put that file here. Okay. So
Okay.
so that what is that file?
UVM
UVM underscore dpi. Okay.
API dot sir.
No, 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 not required. It will automatically take that. Don't give that. It's okay. It will take
Okay,
that.
sir.
Okay. Don't give slash also. It's a file, right?
Okay, sir.
Save it. Save it.
Yes.
And yeah. Okay. Saved it, right? So now run it.
Sir, here package I need to comment it, no, sir.
No, 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 not required.
It's okay.
No, it should. Yeah, it should present. It should be like that in. It won't import and everything. It won't include and import. Okay. Save it and run it.
Okay, sir.
No, just type VC ampersand.
Sir, here only.
Hit enter. Hit enter. Hit enter. Yeah. Now VC ampersand. Enter. Just type PWD. PWD. Yeah, you have that. Go and go. Run it. Run it. Run it. Run it. Tab. Just press tab. Yeah. Hit enter. So base is multiplied in several areas. So just go and check that once. Okay. A lot
Okay.
more things are multiply defined. That means you used it somewhere else.
What does it mean, sir? Multiply?
Multiply defined means you declared it more than once.
Is it like that? Okay, in the list.svh, like for the input, sir.
You have list, right?
Yeah, I have the list one also, but I am not calling the list. In the rundu file, I am calling the top, sir. List.svh, but it was not working, so I have just copied in the top.sv, sir.
Go
And here I am
one
calling
minute.
the top.
1 minute. Top.sv. Okay, fine. So in the just open top.sv.
Okay, here I don't need to.
Yes. Okay.
Yes, sir.
Mm. Again, it is calling all the things again. Okay.
Yes, sir.
Yeah.
Thank you, sir.
So it seems like no, it got not ended. It is actually objections are not getting dropped. Seems like no. Go to this one transcript. Yeah. Now it got no. Go to the transcript.
Yes, sir.
What is the error you have? Just expand that. not there. In the same thing you have plus, right? Just click on that plus. In any one of the window, you can see the plus on the top. Yeah. storage. Oh, okay, fine. Current mem scoreboard. These are the things need to be get run. Okay, so now let's see. So sequence write read happen, right? So what I will do is now, okay, so till now I am not going to do any much coding in this. Okay, so as going further we will introduce some more concepts in this, okay, like how the same sequence can be used multiple times and all. Okay, so or else what I can do is like I can write class sequence n write n read extends UVM, I mean base sequence. Okay, base sequence and class to yy, even for that matter I copy everything. Okay, okay, this is n write n read n write n read. So repeat. So did we use any kind of things? Okay, class mem common in the class, let's make like static in count. Let's make it like, let's take 15. Okay, mem common scope resolution count. If I can go within a different way, okay, so I can use config db resource db. I can get values and all. Okay, right now I am not introducing all those things. Once we go through the config db and resource db, there we will see like how we can actually get these numbers from the test and everything. Actually from each test I can control the respective sequence as well. We will discuss once we will go there. Okay, so I am writing like tick UVM do with request dot write read is equals to 1 semicolon. Okay, that's it. Next what I need to do, that is I need to declare a sequence. I mean this one, let's take like mem transaction queue. So I declare a transaction queue. So what I will do is like whatever the transactions I have, I will put everything into that. Okay, transaction queue dot push back. So it is like request. So why I am doing is like, instead of going with a kind of integer or something kind of like that, why I am completely pushing the entire the transaction in the sense is, if I want anything during reading or anything, if I want anything from the transaction, then I can directly get with this transaction queue. So that is the purpose I am doing this. Okay, for yy again write read is equals to 0. Next here we can do like this. Okay, I can get it here like I can generate one temporary transaction, or I can directly go like this. No, go with the temporary transaction, that's better. Okay. Tx underscore t. Okay. So here tx underscore t is equals to transaction q dot pop friend. Okay, pop friend. Now here request dot address underscore I is equals to transaction underscore t dot address underscore I semicolon. That's it. Okay, So now I can, this is not required for me. Okay. So now this is sequence and write and read. So now I will go here and I'll create one more sequence. I mean one more test case, that is n write and read. Okay. N write and read. So base sequence. Okay, base extended from base test. So here I will directly go and change the sequence n write and read, n write and read. That's it. Sequence dot start. No need to change anything. Rest everything is taken care here. Okay. So simply go here, go with n write n read. Okay. That's it. Go here, invoke the tool, vsync ampersand. So if you see it will allow me to reuse the terminal. So if I hit enter, where is the terminal? If I hit enter, if it will allow me to reuse if I give this ampersand. If I don't give this ampersand, in the sense, until I close this process, it won't allow me to use the terminal. So that is the reason, always try to give. Okay. Run dot. So wave, something is getting happened, like writes and reads are happening. Okay. Sorry, writes and reads are happening. 0 1 5 0 3, I mean 1 5 0 3 1, I mean like that. 1 5 0 3 1 5. Oh, similar kind of things is getting similar data or not. Let's check. So every time, let's take the things here like this. So for example, what happens is, this will give a limited displays. Actually, in the transcript, it will give me a very limited displays. So what we can do is, sometimes what happens is, the log will be in such a huge way, like I can't able to see entire thing in a single transcript window. So that is the reason we'll always go with log hyphen l result dot log. Okay. Slash. Now what happens is, it will create one log file, and inside that log file it will store everything. Okay. Even for that matter, we can say, for every test case I can create one log. Okay. That's also possible. Okay. Like how I can do that is, I can go like this, set test case is equals to test n write n read. Okay. So here, inside, in place of this, I can write dollar test case. So in place of this, test case dot log, dollar test case dot log. So I just need to change here. Rest everything will be taken care by that only. Okay. So now let's see. I'll do the same thing. So okay, error can't read. Okay, fine. I guess there is no semicolon. I mean, there is no is equals to. It is a TCL scripting. Okay. There is no is equals to. If you put is equals to, it won't take. For shell, it requires is equals to. Like there are a lot more things, lot more kind of things. So if you see here, in the functionality area, I can able to see test and write and read.log. Test and write and read.log. Just I'll open this and I can able to see everything here. Okay, so like that. Got it? So if you see, this is the sequence printed. Okay, this is also sequence printed. So because there is no monitor yet. Did everyone understood this? Did everyone
Yes,
understand?
sir.
Yes, sir.
Yes,
So
sir.
simply test case name. So wherever you want test case name, you dollars followed with
Excuse me, sir.
yeah.
Sir, remove that equal to y. It was not taking that.
The thing is like this is the syntax. I mean, how to assign a variable in the uh, TCL scripting is like it is like set followed with variable name followed with the value. Okay.
Okay.
So it won't allow to put is equals to. In shell scripting, without is equals to, it will throw an error. Okay.
Okay, sir.
Generally, I used to go with shell scripting a lot. So that is the reason I put is equals to. So that is the reason it won't take. Okay.
Okay, sir.
Yeah. These are TCL variables. Okay. Now what I will do is I'll go here test and write and read.log. Okay, fine. Now what I will do here is I'll update my monitor because my driver. So I know driver is working fine. Okay, so I can go with assumption. Okay, like 161C1. So that means there is one that is updated somewhere else. FAF7. Okay, fine. The last is one only. FAF7. FAF7. There is the last data 0. There is one more last data that is 0 is happening. Yeah, 0 is happening as 3FEA. 3FEA. So I am getting the similar kind of data. Okay, fine. Now what I will do is I'll try to copy paste my UVM monitor code. Okay. I mean this SV monitor code. So I'll go here. I'll go to the monitor and here simply I will use this one forever begin end. This event forever begin end. Okay, copy, go to mem monitor here in the run phase. So I'll paste this thing here. Okay, right. Now I don't want this put methods. Okay, because that put method is not present here. That put method is not present here because we are not using any mailboxes. We are using TLM ports. Inside the TLM ports, we have a method called write. So this AP port, this analysis port is calling that write method. AP port dot write of just put the transaction. Just put the transaction. So what we are doing is like in coverage and scoreboard, we have write methods, right? So for that, mem transactions are inputs. So that is what I am doing. The memory in the memory monitor through AP port. That means through master ports. Through master port, AP master port. This is like analysis port. Okay, this is the master. Through this port, I am calling this write method and this write method also. So for these two things, memory transactions are inputs. So that is the reason I am giving the transaction. Whatever the transaction that got generated here, that transaction got, I mean, we have given the transaction as inputs. So write, read, address, W data, R data, these are the four things we have.
So you have written in the main monitor AV port dot write.
Yes,
So write method, sir, it is already in the library, sir.
it's present.
UVM library, sir.
We are defining that here. Okay.
So, but without using like this write method, we can also like call the data, na?
Yeah, we are actually calling that. Here the data is getting called.
Yes, what I have done in the memory file, sir, like you have used here like abport.write.
Hmm.
So these one I have not written, sir.
Okay.
Still, I am getting the transaction data, sir.
Where?
In monitor file
Okay.
of my memory, there I have not written apport.write this
Okay.
method.
Okay.
Still,
So,
I am able to get this data in the scoreboard, sir.
so how did you do that? Like, can you share your screen? I'll make you presenter. Yeah, now you are the presenter.
Not happening. It is not happening actually.
entire screen करना
हम्म, होगा जब तक।
go to
Yeah, I can see your screen.
Yes, sir.
Mhm.
Sir, here the SPD part, like what I want to say, like you have written here, here, sir, like AP, uh,
Yes.
AP port
Mm.
dot write.
Yes.
So it is mandatory, sir, to write like this line, sir, this expression.
If that line is not there, assume, okay, your coverage and your scoreboard, right method is there, right? It is actually expecting an input.
Okay.
You're actually expecting an input, so that input from where we can provide that input. Got it?
Okay. So from monitor it callbacks, it is calling, sir.
Yeah. So if it is getting called in the sense, if it is getting called in the sense, some, I mean, this is, so from where it is getting called.
From the monitor. Na?
So, so if you see the monitor, just open the monitor. So now we included that in the line number 28,
Yes, sir.
right? So without that calling, how it will do?
Got it, sir.
Got it?
Thank you, sir.
So now I placed everything into the right method. Inside transaction, I got everything. Okay. Under this transaction, I got everything. So for that matter, I can directly go with cover group.sample here only. Okay. cg.sample. I can directly write like this. It's also possible. Okay. It's also possible. So the thing is like instead of going to the run phase, I can directly go here itself. Okay. cg.sample. Now I'll go to the coverage part memo. go here. So inside this one, I'll paste things like this. Okay. So what I can go here, what I can do here is, first of all, I need to declare some memory. Okay. Int, or let's take like bit width minus 1 down to 0 mem star, or I always go with int instead of star. Okay. Yeah. So width minus 1 down to 0. So now I have the memory. So what I can do is like, I actually cached this to this transaction. So now whatever the things that was there here, that was present. Like whatever the things there here, that was present. Even I can go like this, or I mean, I don't want this one. Okay. So now this is more than enough for me. Or else you can dump that into the queue and you can get it here, and you can check like the things is there on not. So the better option is go with the queue. Okay. Go with the queue. That is the best way. If you ask me, that is the best way. I mean, if there might not be any chance of missing the data. Okay. So what I will go is like transaction queue of dollar. So go here. I mean, this was not required right now. So transaction queue dot pushback of that particular thing. Okay. So now what I will do is like, I will get it from here. So forever begin transaction queue is greater than 0. Okay, greater than 0. Then once that happens, then I will do like transaction is equals to transaction queue dot pop friend, pushback and pop friend. So now I have the transaction. Okay, here pushback and is pop friend. So now I have the transaction, and inside that transaction I am checking, is this happening or not. If this happen, what we need to do. So actual output, expected output. So I wrote lot more things. So I need to copy that as copy. So okay, I use the same way. Fine, super. Paste. Yeah, done. So now, so where I need to do that in scoreboard, I generally used to, I mean, the scoreboard kind of logic creations I generally used to do in the top module. Right here, where I can do that is, I can do that in the test library. I can do that in the test library. So before going to that, so first what I do that is, I need to compare whether the prints that my model is giving is correct or not. If this was wrong, in the sense coverage on scoreboard will anyway get lost, right? So that is the reason what I will do is, instead of going to the 15 kind of things, I will go with 5. Okay. So count of 5. Now what I will do is, I'll simply print my driver request.print and monitor transaction.print. Fine. Now let's run this code and let's see what will be the outputs are. If both are correct, in the sense, let's go and implement the scoreboarding checking and everything. Okay. Line number 29. Mem monitor. So this mem monitor, line number 29. Okay. So this was not actually needed. Oh, sorry. Transaction TX. So now what we need to do, that is, if transaction is equals to transaction scope resolution type ID scope resolution create. So we have only one argument because this is a object. Yeah, now let's run this one. So, and one more thing is a score failed to find. Okay, now mismatches and mismatches. Okay, load file common. Okay, static int num matches mismatches. Done. Now run this one. Okay, so something, there are errors, could not find method on write read in the transaction of transaction dot write read. Okay, there might be some, it is a kind of these monitors. Okay, p address underscore I, w data underscore I, r data underscore o. So now let's go to the scoreboard. Similar kind of things also issued here, I guess them. So, yeah, write read underscore I underscore I underscore I underscore o underscore I. Okay, let's check, is there anything that got missed? Matches, mismatches. Okay, fine. And one more thing, coverage. This one is also there, right? Coverage. So everywhere it is like underscore I address underscore I. Okay, so this was not required. Yeah,
Hello, sir.
yeah.
Sir, here we are going to create the memory of the CG handle with new keyword only, or like UVM style, sir.
It is, I mean, this, the thing is like there is no concept of cover groups that was specially implemented in the UVM. Okay, it comes as a part of SV only. So whatever the SV cover group is there, exactly the same way we need to implement it here also. Okay,
Okay, sir.
so that is the reason we need to use is equals to new. So that is the reason I am not using that tick new component. Instead of that, I used like this. Okay,
Yes, sir.
so now this also got updated. Okay, so now let's see. Now let's see w data 617. So seems like where are the monitors? Tab, test test library. Sorry, do we got the monitor out everywhere anywhere? So the thing is like monitor is not getting updated. Okay, tab new test and write and read. So the thing is like there is no monitor updates we can see here. So now what we can do is like we can go to the monitor and let's, the thing is like this is not at all getting implemented. Okay, that is what the issue is. So go and update with the clocking block. Okay, so for that I require tab new mem interface. Okay, so next, so I didn't implement a clocking block here. Is this a full-fledged code? Okay, fine. Okay, this program is actually doing that. Okay, fine. A mem interface. I have this one, so I'll copy the entire one. Even for that matter, I'll copy the entire clocking blocks. Okay, copy. I'll go here, mem interface. I'll paste it. Okay, clocking block. Now it is monitor clocking block. Go here and update it with VAF dot monitor clocking block. Monitor CB, and let's try to observe. Okay, let's try to observe whether these things are happening or not just by changing the clock. If it was not getting happened in the sense, then we will go and update the entire code. Okay, so let's try to do that once. Yeah, I am getting the monitor outputs now. Okay, I am getting monitor outputs. Let's go and upload the file, load the log. So now, so I'm getting why log not updated. No, here log got updated. Okay. This log is actually okay. Got it. So it is of actually useless for us. Okay. So actually, what is happening is like log is continuously getting appended. Okay. Fine. I understood the situation. So now let's see. Here, address 1 WDA 61C1. Address 1 61C1. Okay, fine. Next 5 4F94. 5 4F94. Next third one 07C65. 07C65. Okay. Next 38357. 38057. Okay, fine. Next 17616. 17616. Okay, fine. Next, write it 0, 17616. 17616. And the latest updation is 17616. And what is the first data item we have written? 617. So that anyway got lost. Okay. Because the data is getting overwritten. Fine. So, okay. This is 0. Write it 0. Yeah. So this is the first read 07616. 0761. I mean, sorry, 17616. Okay, fine. Next, address 5 4F94. Address 5 4F94. Address 0 7C65. Address 0 7C65. Next, address 3 8E57. Address E8057. Okay, next address 1 7616. Address 1 7616. And these are the last data. Okay, so let's go and observe the same thing in the waveform as well. So the last 7616, next 5 4F. Okay, next 07C 380 17616. So all the data, whatever the data that we have there, that all got like the same way. The monitor is also seeing the same data. Okay, monitor is seeing the same data. So now I can go with coverage and everything. So already that coverage is also done here. So let's see. Yeah, so addresses is not getting properly covered and everything fine, not an issue, because many of the things are not getting generated. I am just going with the 5 type, 5 only. Okay, only 5 only. Okay, so now let's see. So the log file size also getting increased. Okay, because the thing is like it will anyway append, because of the same name, right? It will anyway get append. So that is the reason what generally generally we will do is we will go with the time. Okay, log name underscore times and everything. So defining time format in TCL is somewhat complicated in the sense it's like very big, so that is the reason I am not telling that here right now. So if you see, the log file size is 104 KB. Even the entire coding is not 104 MB, 104 KB, but this is 104 KB. Okay, so that is the reason I generally used to delete. Okay, okay, again get created one more time if I run this one. Okay, so fine. Now what we need to do here is monitor is sampling correctly. That we understood that. Now what we need to do is we need to check board logic. So where we will do that is, for every test we need to check, right? So that is the reason in the base test I will write report phase. Okay, function void report phase, and the function UVM phase. Okay, so in the report phase, okay, if you want, put it here. Okay, test report phase, report phase of the test. So now here I am checking if begin end so UVM sorry, here mem scope resolution matches. Okay, and mem common scope resolution num mismatches is equals to 0. That means matches, right? So in such kind of situation I'll say like test is getting passed. Test passed. Test passed. So matches is equals to percentage 0d slash d, matches is equals to percentage 0d. Okay, so the thing is like, so for that I will use all the things. One, so I need to add 4 more things. 1 2 3 4. Yeah, dollar yes format here, common num matches comma mem common scope resolution num mismatches yy Let's go. That report phase will be present for each every test case where the scoreboard is getting with 5 matches, 0 mismatches. Okay. One, two, three, four. So matches 5, mismatches 0. So test is getting passed. So fine. Now I can go with mem common and I can go with like 15. So matches 15, mismatches 0. So the test is passed. Yeah. So now fine. So that means my scoreboarding is also got completed here. Got it? And if you want to see tab new test underscore, the test is not getting created. Log UVM memory test bench. So I removed that log. Test case.log. Yeah. Memory test bench functionality. Somehow it not created fine. It's not an issue for me. Okay. So the thing is like we got that created, right? Did everyone understood this? Did everyone understood this? How we will do that?
Yes, sir.
So this is how we'll used to develop a test benches. So now once everything got set, we won't touch anything. Okay. We think we'll always try to work on the test library and sequence library and the common. Someone will call config, someone will call common, but names are different, but the working functionality is of same. Okay. So test library, sequence library, and common. Okay. These are the 3 files we will use as the top level files to control the entire test bench. Got it?
Yes, sir. Got it.
Yeah. So now let's see. So any doubts? So before continuing, tell me like, is there any doubts in the EVM test bench?
Yes, sir. One doubt only, sir.
Yeah.
Like
Yeah.
actually,
What is it?
that generation of the test case and the that test cases class we are extending from the base test
Yes.
class, sir.
Yes.
That part, sir, can you explain it, sir? Like,
Okay. So you're asking like this one. So these are the base test. Okay. What and all the things that was common for each and every test case that we will mention in the base test. Okay.
yes, sir.
So in this base test generally extends from UVM test. Okay. So if
Yes,
every
sir.
test is extended from UVM test, in the sense I need to write everything in each and every test case. Okay.
Yes, sir.
So that is the reason what I will do is I will create one base test. Okay. Inside that base test, what and all are the things that was common to each and every test. Okay. I will put on that. Okay.
Okay, sir.
So and then I will extend every test from that base test. Okay. So
Okay, sir.
right now, Yeah. So this test, right, this is extended from base test. So base test in the sense, inside this test all these will present. Okay. So now if you see, what is the advantage of doing that is, my actual test cases are getting very actual test case coding is very less. If you see, this is one test case. Okay. This is one test case. Just if I want to if I remove these comments, hardly, if you see, 1 2 3 4 5 6 7 8 9 10 11 12 13 14, hardly 14 lines code. Okay. Right. If, for example, if I am not doing such kind of things, then apart from 14 lines I need to do these things: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 and 25. 25 plus 11. Okay, almost all, at least 36 lines of code will be present for each and every test case. So which is better?
Sir, can you go to phase uh, start objections here
Here.
in the run
Okay,
phase?
1 minute. Here. Yeah.
In the that base test, sir, first.
Base test. So in base test we won't do any objections, we won't raise any objections. Generally I won't keep any run phase in the base test. I won't write any run phase in the base test.
Okay,
Okay.
so there is no run phase.
There is no run phase.
So how we are going to say, sir, call that child classes? Like, I'm not able to get it, sir. Actually, this
Like,
one.
what exactly you are not getting, please tell me that, I will
Like,
clarify it.
suppose, sir, I have created one base test. Okay, okay,
Okay.
and there are multiple test cases I need to write. So I'm gonna create like multiple test cases class. Suppose write, read, and write, read both.
Okay. Okay.
So inside the base test, I am not writing the run phase. Then how we are going to call that child into base test? Because
So
from the base test, it is
child in
calling
the
that
base test. What is the child in the base test? So
child.
you see, this test, right, is actually child to base test, right?
Yes, sir.
So what and all are the things that was written in the base test? Okay. I am taking everything. I, in the sense, my test right is taking everything. Okay.
Yes, sir. Yes, sir.
On top of that, it is writing one more coding.
Yes, sir.
So now what happens is, if there is a test phase, if there is a run phase written in this, in the base test, assume there is a run phase written in the base test. Okay.
Yes, sir.
Now what happens is, this run phase, this child test right run phase will going to override that run phase of base test.
Yes,
Okay.
sir.
So that is what generally will going to happen, right?
Hmm.
Right. Accept it
Yes, sir.
here. So what I am doing here is, I am not writing that run phase inside my base test. Even though it will present, even though by default it will present, but that is getting overridden here. Okay. This run phase from line number 56 to 79, whatever the run phase is there, that run phase is going to override the run phase that was present in the base test.
Okay, sir. So then what is the flow, sir? Like how it is going, like how the right is right child class, then read child classes test case is going to call.
You are calling only one test case, right? One
Where,
test
sir, we are
case.
calling?
We are calling only one test case at a time, right?
From the Rundu file, sir, only.
From the run do file. Assume from the run do file, I am calling only one test case at a time, right? I can't able to execute more than one test cases.
Sir, can you show that test case where you have written in the code, sir? Test case part.
In the test library.
No, the The logic's a test case logic, like where you are calling that test case, like WREN from the rundu.
Okay, you are telling like from where this is getting called.
Where it is called, like in which class it is called, sir?
It's getting called in the top module. Okay,
Okay, okay. In the top module.
top module. This one is calling that.
Okay.
This one is calling that. So
So
what happens is here we are writing base test, right?
yes, sir.
So if I am not passing this one here, if I am not passing this one, line number 8, if there is no line number 8, then base test will going to get executed. Okay. If there is
Yes.
a line number 8, like this one, UVM test name, okay, then whatever the test case we are passing, that test case will override this argument. Okay.
Okay. So this one is the predefined one, no, sir. Like we don't need to define any test case.
Where predefined one,
Like
which one you are
in
talking?
the rundu file, that variable test case variable.
This UVM underscore test name.
Yes, sir. That set one also, like fifth one.
Fifth one.
Yeah,
This is
that
this
variable.
this is TCL variable. This belongs to run dot do. This there is no nothing to do with this one with the UVM. Okay.
Uh, yes, sir. That one I got confused, sir. That's why
This
I'm
is
not
this is
able to get it like how it is flowing the data.
TCL variable. Okay.
Yes, sir. Got it, sir. Now got it.
So this TCL variable is nothing to do with the UVM. Okay, remember this one. Okay. So what I am doing is like just for the automation. Every time I in the real time what happens is like this rundu kind of things will be a very huge files. Okay. So inside that if I want to change some things, I need to go and update in different areas of the same rundu, or they will do kind of make file kind of things. Okay. So inside instead of doing that, going to each and every line and updating the things, what we will do is like we will set some variables. Okay, I'll just update here. Okay, that variable will get updated automatically everywhere in the rundu. Got it?
So we can write like one command like after like write test case we there may be test case will happen, then again test NWR and RD will happen,
that
like
is
three test case.
that is called regression. Okay,
Okay.
that is called regression. So regression we will do that at the end. Okay, regression is
Okay.
like easy, it's not a big task. Regression means what we will do there is like we will maintain all the test cases we have. Okay, and we'll put all the things in a single file. Okay, after that what we will do is we'll write one small script. Okay, we'll write one cute script. Okay, so what that script will do is like it will read a test name from that file. Okay, and then it will put the test names here, and it will start executing that. Once that got completed, it will take the test case from the test list file, and then it will re-execute the same process for, I mean, it will re-execute everything. Okay, like kind of things. Okay, compilation won't happen, elaborate will happen. So sometimes if we are doing that for code coverage, optimization is also required. So optimization, elaboration, adding wave, like at the time I during regressions I won't see waves and all. Okay, so I'll remove that and just completed. It will continuously take the test case and everything. It starts executing the whole flow. Okay, and it will the test.
Yes, sir.
That is how the things are going to happen. Regression, it is not a big difficult task, it's a very small task. The thing is like after this I will put one while loop. Okay, one while loop, that's it. Inside that while loop I'll put all these things. That's it. Regression is done. Okay, it is that
Okay.
simple. So at the end of the things we will see how regression will happen. So what is the requirement of regression? Okay, what is check in, check out, and everything. Okay, we will do that. We will check. We will see that and everything. Okay.
Okay, sir. Sure.
Yeah. So, any doubts for this before continuing to the theory of UVM? Doubts? 10 minutes. We will start at 4:15. Okay, 5. Okay.
Okay, sir. Thank you, sir.
Yeah. Thank you.
This conference is no longer being recorded.